See this problem. An electron emitted by a heated cathode and accelerated through a potential difference of 2.0 kilovolts enters a region with a uniform magnetic field of 0.15 Tesla. Determine the trajectory of the electron. If the field is transfers to its initial velocity, makes an angle of 30 degrees with the initial velocity. Our motive is some electrons are projecting out from a cathode ray like this. Due to an electric field, the electron got accelerated. These electrons are entering into a magnetic field. We need to find out that the path traced by the electron or trajectory of the electron. That is our motive. Two cases are discussed here. One is an electron is traveling transverse to the magnetic field like this, or it is making some angle with the field. So in these two cases we need to discuss the trajectory of the electron. That is our motive. Now I am coming to investigation part. The given things are the potential difference which is accelerating the electron is equal to capital V is equal to 2.0 kilovolts. That is equal to 2 into 10 to the power of 3 volts. And the magnetic field B is equal to 0.15 Tesla. And in second case, the angle made by the electron with the magnetic field is equal to 30 degrees. And we know charge of electron E is equal to 1.6 into 10 to the power of minus 31 coulomb minus 19 coulomb, and the mass M is equal to 9.1 into 10 to the power of minus 31 kg. Now coming to the resolving part. Whenever an electron projecting into the magnetic field in a transverse direction, it will trace a circular path. Assume that this is uniform, and if an electron is entering perpendicularly, it will trace a circular path like this with some radius r. So here also the force which is experienced by the electron to put it into the circular path is called centripetal force, which is mv square by r is equal to, the force is due to electromagnetism, so that electromagnetic force F is equal to QEB. In this case it is EVB. From this I can write R is equal to mv by EB. But this is the velocity of the electron. So that velocity of the electron is due to the projection of electron under electric field. So electric field energy EV is equal to the energy gained by the electron, that is kinetic energy, half m v square. So from this V is equal to 2 EV by m whole to the power of half. Using these two formulas we can find the radius of the curved path taken by the electron under magnetic field. R is equal to mv by EB, that implies m into, I'll substitute the value of V, that is 2 EV by m whole to the power of half divided by EB. If we bring this mass and charge and field into that square root, we will get m square into 2 EV by m into E square B square whole to the power of half. M gets cancelled, E gets cancelled, that is equal to, the remaining things are 2 mv divided by E B square whole to the power of half. That is equal to 2 into 9.1 into 10 to the power of minus 31 into 2 into 10 to the power of 3 divided by 1.6 into 10 to the power of minus 19 into 0.15 into 0.15 whole to the power of half. That is equal to 2 into 2 4, 4 into 0.4 is equal to 1.6. I am writing integral part at one place. 9.1 divided by 0.4 into 0.15. So 0.06 into 0.15 into 10 to the power of minus 31 plus 3 minus 19 whole to the power of half. That is equal to 6 15s are 90, and you need to put after 4 digits, so you will get 9.1 divided by 0.0090 into 10 to the power of minus 9 whole to the power of half. That is equal to 9.1 is nearly 9 to 9, so you will get 1.01 into 10 to the power of, this is minus 3, 10 to the power of minus 3. So using this I am writing minus 6 whole to the power of half. That is equal to, it is nearly 1 into 10 to the power of minus 3 meters, or 1 millimeter. So the radius of the circular path traced by the electron is equal to 1 millimeter when it is projected perpendicular to the field. Now we need to resolve for the path when the electron is projected with an angle 30 degrees into the field. So assume that this is a uniform field. An electron projected in such a way that it is making some angle with the field theta. So the horizontal component of this velocity of the electron is equal to v cos theta, and the vertical component of velocity of electron is v sin theta. The horizontal component of velocity tries to move the electron in the direction of the field, and the vertical component of the velocity tries to make circular path. So in that case your electron will trace helical path, because one is pulling in this direction, another is pulling in this direction, so you will get like this. So this is called helical path. So for this helical path we need to find out the radius of this circular nature. So for that we need to consider the vertical component. Then r is equal to m into ev by m whole to the power of half sin theta, because this is v and this is the sin theta. Along with this we can call it as vertical component, divided by eb. We already know the value of this, that is 1 millimeter, or 1 into 10 to the power of minus 3 into sin 30 degrees. That is equal to half into 10 to the power of minus 3, or 0.5 millimeter is the radius of this helical path.